Okay, so we want to talk a little bit about free variables and parametric representations. Okay? Okay, if you got 3y plus 5x equals 7, you can solve that. Get this, right? Okay? So the graph is a set of points, x, y, that satisfy this. Okay? This is totally equivalent, algebraically and graphically, to two equations. Okay? In other words, if I make a table of x versus y for various t values, okay? Well, let's say t equals 0, then x equals 0, and y equals 7/3. Let's say t equals 3. We're going to go in multiples of 3 so we don't have to deal with too many fractions, okay? Actually, maybe I don't. Let's see. Let's say t equals 2. Then x equals 2. And y equals, well, negative 5/3 of 2 is negative 10/3. Negative 10 and 7 is negative 1. Okay? Or it is 3, so you get negative 1. Okay? And then I bet you if y equals 5, it's going to come out another multiple of 3. Okay? Because y is 5, that's negative 25/3 plus 7/3, negative 18/3, right? That'd be negative 6. And x, of course, would be 5. And let's just do one more. 8 would give us negative 40 and 7/33, negative 11, and x would be 8. We could graph these points, 0, 7/3, and let's just say 1's here. Well, no, we need to go all the way up to like 11 here, so let's just put 10 here. Half of that would be 5, and then we can do this. Just get an approximate graph. So 7/3 are down here just between 1 and 2. So we'd have a point here. If x is then, okay, x goes up to 8, subdivide that, we get 4, subdivide that, we get 6, here's 2, here's 1, and so forth. Okay, so when x is 2, y is
Negative 1.
negative 1. I should have labeled these in the negative direction. Here's negative 10. Here's negative 5. Well, 2 negative 1 is going to be about here. Okay? 4 negative 6 is going to be about here. And 8 negative 11 is going to be about here. These points are plausibly in a straight line, even though it doesn't look like it. If you calculate the slope between any of these two, you're going to get negative 5/3. And every one of these points, for example, just take 5, negative 6. Well, if x is 5, that's 25, right? If we want to get 7, then we've got to subtract 18, so y would have to be negative 6. Okay? In other words, plug these points in. Negative 18 and 25 is 7. Okay? 40 and negative 33 is 7. Okay? So this is the graph of the parametric equations, and it is the graph of the original equation in either form. It has a slope of negative 5/3. Calculate slope between any of these 2 points. Totally equivalent. But we write it like this. Okay? Now, you would say that we could say X is your independent variable, Y is your dependent variable. Meaning you assign values to X and your value of Y depends on them. So if you have a value of X, you're going to get a value of Y. Okay? Here we're going to say X is a free variable. Okay? Or we could say that T is a free variable. For any value of T, we get a point on the graph. Okay? Okay, well, let's take the equation now. 2y plus 5x minus 3z equals 9. Okay? Well, now you got two free variables. You can assign a value to either any two of these variables, and then you get the value that the third variable has to have. And those two variables could have any values at all. Okay? So we could solve this. We get z equals just decide what order I want to write them in. Doesn't really matter. Okay? X and Y can be regarded as free variables. They can take any value at all. And when you have a value of the two free variables, you automatically then get your value of z. We could write this in parametric form.
Excuse me.
Okay? Now the set of all the points that you get, of course, if you have to have values of u and v, well, all the values of z that you get along with the values of x and y that come from your values of u and v give you a plane three-dimensional space. Okay?
Okay.
So that's the idea of a free variable when you reduce a matrix. Okay? Okay? If this is x1, x2, x3, no, this column's your x1, x2, x3, instead of simultaneous equation, then x3 is free. Once you have the value of x3, you can find the values of x2 and x1. Okay? Whatever these numbers are, you multiply by the value of x3. Okay? So x3 is free in this sense. Okay, so you're going to see that right at the very beginning of the first chapter when you get to it, so I wanted to talk about it a little bit. Okay? Go ahead and use that terminology yet. Some filling in a little terminology in the first couple of chapters. Okay?
Okay.
That's one of the terminologies. You'll see the examples straightforward. Okay?